Hello, today I will discuss a free particle in 1D box. Right. Let us consider a free particle in x is equal to 0, x is equal to L. Let the box of one wall is at x is equal to 0, another wall is at x is equal to L. Let a particle inside a box is moving freely. That implies free particle. The potential is equal to 0. That simply inside the box the potential of that particle is equal to 0, and outside the potential is infinity. Because of the particle cannot go outside because of that infinity potential. Okay, that implies the potential is infinity outside and the potential is 0 inside the box, that particle. And the wall, these two wall like a infinity wall for that particle. Okay, the potential can be written as V of x is equal to 0 inside the box. That implies 0 less than x less than L, 0 to L, the potential becomes 0, and is equal to infinite elsewhere. Okay, the potential of the free particle inside a box can be written in this order. And we can find the wave function of that particle and energy of that particle by using the Schrodinger time independent equation. That is, we know already the Schrodinger time independent equation. That is, know the time independent Schrodinger equation. We already know what is that. That is dou square psi by dou x square plus 2m by h cross square e minus v psi is equals to 0. Whether this psi is the wave function of a particle inside the box and this energy is the wave function of that particle inside a box. That is energy. Let us see how that energy varies and how that wave function is varies according to particle. Okay, so inside the box the potential becomes 0, so that quantity is equal to, so the Schrodinger equation becomes dou square by dou x square plus 2m by h cross square e psi is equals to 0. This equation can be written as dou square psi by dou x square plus k square psi is equals to 0. Okay, this is a second order differential equation. So you already know in mathematics how to solve the second order differential equation. That is, first of all we write the auxiliary equation of that differential equation, that is d square plus k square whole into psi is equals to 0. That's simply d square plus k square is equals to 0. Okay, that's why d is equal to plus minus ik, and we see that the roots are complex, so its solution becomes psi is equal to a cos kx plus b sin kx. Okay, this is the wave function of that particle. Then which apply boundary condition of that particle. We can apply the boundary condition. What is it, boundary condition? You know, at the boundary the wave function becomes vanishes. Okay, at the boundary the particle does not exist. At this boundary, at x is equal to 0 and L, the psi becomes 0. Inside the box the psi becomes exist, outside 0, and on the wall becomes 0. So the first boundary condition is x is equal to 0, psi becomes 0. So apply that equation, so psi becomes 0. Okay, 0 is equals to a cos 0 x 0, so cos of 0 1, so a, so b sin 0 of 0 is equal to 0. That implies we get a is equal to 0, so that equation becomes psi is equal to a0, that's why b sin kx. Got it? Okay, then apply second boundary condition at x is equal to a L, the psi must be 0, so apply that equation, this condition, apply that equation, that is equal to 0 is equal to b sin kl. Okay, that implies sin kl is equals to 0. That implies kn is equal to n pi, k is equal to n pi by l. this condition, and we write the wave function of that particle becomes, we know psi is equal to b sin kx. So psi is equal to b sin, put the value of k, that is n pi l by x. This is the wave function of the free particle inside a box, and we can calculate the value of b by using normalization condition. The wave function is normalized, so apply the normalized theorem, that is limit 0 to l psi star psi dx is equals to 1. By applying this condition, we can find a value b. Let us apply this condition. Okay, we know psi is equal to b sin n pi by l into x. That implies psi star is equal to, it's a real quantity, so psi star must be b sin n pi l by x. So psi into psi star becomes b magnitude square sin square n pi by l into x. So apply this condition in that equation, that is psi star psi dx is equals to 1. That implies apply outside the constant b mod square, that is 0 to l sin square n pi l by x is equals to 1. By calculating this integral, l by 2, okay, is equal to 1. That implies b magnitude is equal to 2 by l under root 2 by l. So put that value in that equation, psi is equal to under root 2 by l sin n pi x by l, okay, for nth, okay, nth wave function. Okay, the wave function is that. And how can I calculate the energy of that particle? We know total energy of nth particle is equal to kinetic energy plus potential energy. Okay, kinetic energy plus potential energy, and we know already the potential energy is equal to 0 inside the box. So the total energy is equal to kinetic energy. Kinetic is nothing but p square by 2m. We know p is equal to h cross k, that implies we can write h cross square k square by 2m. Okay, so h cross square by 2m, we can put the value of that k value. We know already k value n pi by l, that implies n square pi square by l square. That implies energy of that free particle inside the box is equal to n square pi square h cross square divided by 2m l square. Okay, so this is the energy of a free particle inside the box. This is the wave function of a free particle inside the box. Okay, so the diagram of wave function with respect to coordinate, let the box becomes x is equal to 0, x is equal to l. Okay, for n is equal to 1, the diagram of the wave function, let for nth state, remember n minus 1 number of nodes exist. Okay, that is for n is equal to 1, that means 0 number of node exists, that means the wave function becomes this like. Okay, this is the middle l by 2. Okay, for n is equal to 2, that's when 1 number of node exists, that means the node is here, that implies the wave function becomes this like. For n is equal to 3, that means the second excited ground state, first excited state, then second excited state. Second excited n is equal to 3, that implies 3 minus 1 number of nodes is equal to 2, that's means here one node, here one node. The function becomes okay. Then the psi mod square probability density, here is the important role. So let us have the structure probability density, x is equal to 0, x is equal to l. The probability psi is this type. Okay, okay, the probability density psi mod square here be this type. Okay, and for n is equal to 1 ground state, n is equal to 2 first excited, this is the l by 2, the probability density becomes okay. Here the wave function this type, for n is equal to 3, for n is equal to 3. Okay, the probability density becomes this type. Okay, clear? So note this is the node. For nth state, n minus 1 number of nodes exist in that diagram. Okay, then another is in psi 1 for first ground state, the probability is maximum at what point? The probability is maximum at x is equal to, for n is equal to 1, L by 2. Okay, for psi 2, the probability is maximum at x is equal to that position, that is L by 4 and 3L by 4. That's why L by 4 and 3L by 4. So remember, for nth state, that is psi n, the probability is maximum at x is equal to L by 2n, then 3L by 2n, then 5L by 2n, this like. Okay, for nth derivative. Okay, you can then we will discuss 0 point energy. 0 point energy. What is 0 point energy? We know the energy of a free particle inside the box is equal to n square pi square h square by 2 ml square for nth state. Okay, for n is equal to 1, that is ground state. Energy becomes E1 is equal to pi square h square by 2 ml square. Okay, that is the minimum energy. That is the ground state energy is the minimum energy. In classical, we know the minimum energy is equal to 0, but in quantum mechanical there exists a minimum energy, that is called 0 point energy. That is called 0 point energy. If the 0 point energy is equal to 0, if the minimum energy is equal to 0, let us minimum energy is equal to 0, that means the particle is at rest. Okay, that means particle at rest, x is equal to rest, minimum energy, that means 0 energy. If energy is equal to 0, okay, particle is at rest, that means change in position is equal to 0 according to Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay, that is product of del x into del position and momentum is greater than equal to h cross by 2. If the del x is equal to 0, del px becomes something by 0 is equal to infinite, which is not possible. Okay, so again the Heisenberg time energy relation, E is equal to 0, that means we know del E into del T is greater than h equal to x squared by 2, that's when energy is equal to 0, that means del T tends to infinite, which is not possible. Okay, that's why the minimum energy becomes some exist, that is the called 0 point energy. Okay, that is in quantum mechanically 0 point energy exists, but classically there is no 0 point energy, that's 0 point. For instance, without the 0 point motion, atoms would not be stable, for the electrons would fall into the nuclei. Okay, without 0 motion, let us this is atom. If there is no 0 point energy, that means the energy becomes 0, that's why the electron which is revolving around the nucleus is overlap at the nucleus. Okay, that's why there is a minimum energy which is called 0 point energy. For free particle there is a 0 point energy, also a hydrogen atom there is a 0 point energy.